Okay, this exercise 10F, again, it's counting, and we're looking at permutations where order matters. And in this exercise, we're counting with identical elements and cases. So what that means is if we have n different objects, so the number of different ways of arranging n objects in which A of the objects are of one kind, B objects are of another kind, and say C objects are of another kind, and so on. So normally if you just want to arrange n objects, it's n factorial. But because there are A objects of one kind, B objects of another, and C objects of another, and they're identical, you have to divide by A factorial, B factorial times C factorial. Okay, and obviously A, B, and C, the sum of A, B, C has to be less than n, because yeah, like that might be 20 objects, this might be 2, this might be 3, this might be 4 objects or something like that. But A, B, C are subsets of n, okay? So just an example here, find the number of ways in which 4 identical wine glasses and 4 identical tumblers can be arranged in a line. So I'm going to go wine, 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 tumbler, 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 tumbler. Now, if I just want to arrange, so number of ways, if I just want to arrange these 8 things, it would be 8 factorial, right, ways. But, you know, you can't distinguish between the different W's, and you can't distinguish between the T's. So we have to divide by 4 factorial because there are 4 W's, and 4 factorial again because there are 4 T's, okay? That gives us 70 ways. Says, and how does this change if one of the wine glasses is chipped and 2 of the tumblers, so 2 of those tumblers are replaced with 2 other tumblers that happen to be identical? So now what we've got, I'm going to go, we've got W, W, W. Now one of the wine glasses is chipped, so I'm just going to call that little w, okay? And then we've got 2 identical tumblers, I'll call them capital T's, and then they're replaced with 2 other identical tumblers, and I'll call them 2 little t's. So really what I've got is 3 W's, 1 little w, 2 t's, and 2 little t's. So the number of ways I can line those wine glasses and tumblers up, we have to count how many there are. So it's 8 factorial ways. However, there are 3 repeats of the wine glasses. I don't need to divide by 1 factorial because 1 factorial is just 1. Over 2 factorial for the 2 tumblers that are the same, and 2 factorial again for the other 2 tumblers that are the same, and this gives me 1,680 ways. So number of ways to line up the, I'll just call them cups, okay? Okay, so obviously you end up with more ways because there are more different types, okay? We'll find the number of permutations of the word committee. So committee has got 1, 2, 3, 4, 5, 6, 7, 8, 9. So number of ways to arrange the letters, that's what a permutation is. So number of ways to arrange the letters is 9 factorial over, however we've got 2 M's, we've got 2 T's, and we've got 2 E's. So divided by 2 factorial times 2 factorial times 2 factorial. 2 from the exercise, the digits 1, 1, 1, 2, 2, and 3 are used to form a 6-digit number. Find how many numbers can be formed. So those numbers have to be, we have to form a 6-digit number. So we're going to be using all the digits. And the number of numbers, again, just same as before. We've got 3 1s and we've got 2 2s, and we've only got 1 3. So we have to divide by 3 factorial for the 1s, okay, and we have to divide by 2 factorial for the 2 repeating 2s. Okay, so there are 60 different ways, because remember, you know, these 3 1s can't be distinguished from each other, and neither can those 2 2s. And 5 identical green chairs and 3 identical red chairs are arranged in a row. Find how many arrangements are possible if there are no restrictions. Well, that one's, you know, just straightforward. So it's 8 factorial over 5 factorial for the green chairs and 3 factorial for the red chairs is find how many arrangements are possible if there must be a green chair on either end. So I'm going to go green, 5, 6. So we've got 8 chairs. 1, 2, 3, 4, 5, 6, 7, 8. And these have to be green. So really what I need to do is I need to arrange. So they're a definite. That's a 1. Only one way to do that and one way to do that. I just need to arrange the other 3 green and 3 red chairs. Okay, because these, only one way to do that and one way to do that. Okay, so therefore the number of ways is going to be 6 factorial over 3 factorial times 3 factorial, which is 20 ways. So again, you know, these are restrictions, so put them in first. There aren't, remember all the greens are identical, so you just put a green there and a green there, and there's just one way to do it, okay? Example here, in a 10-question test, so if a test is out of 10, and you get 1 mark for each question, in how many ways can a student score 7 out of 10? So it means that they must have got 7 correct and 3 incorrect. So it's like I'm arranging 7 C's and 3 I for incorrect, okay? So that's just going to be 10 factorial over 7 factorial times 3 factorial, okay? I'm really trying to do, it's like I'm trying to arrange a word with 7 C's in it and 3 I's and just see the number of arrangements, okay? So it's similar to, well, it's just done really exactly the same way as that, okay? So 10 factorial over 7 factorial times 3 factorial is 120. Now part 2 says, for what other mark is there the same number of ways of achieving it? You know, we're dividing by 7 factorial times 3 factorial. You would get the same answer if you had 7 incorrect and 3 correct. So it would be for a mark of 3 out of 10, because that would be, you're arranging 7 I's and 3 C's. That again would be 10 factorial over 7 factorial times 3 factorial, which is 120 ways. So there are basically 120 ways to get 7 right and 120 ways to get 3 right. Because if you get 3 correct, you're getting 7 incorrect. And if you're getting 7 correct, you're getting 3 incorrect. Okay? So we're going to look at that connection a little bit later. Okay? And 8, find the number of arrangements of the letters in the word sloops, S-L-O-O-P-S, if there are no restrictions. So we've got 1, 2, 3, 4, 5, 6. That's just going to be 6 factorial over, we've got 2 S's, so it's 2 factorial. So notice we've got 2 times O and we've got 2 times S, so we've got to divide by the repeats. So it's 6 factorial over 2 factorial times 2 factorial. Part 2, it says how many arrangements are there if the 2 O's are together. So I'm going to put the 2 O's together, that is one group, and then I have to arrange the S, the L, the P, and the other S. Okay, so it's like we've got a total of 5 groups to arrange. Now I don't have to order the O and the O. I don't say, well, I've got 5 groups. Normally what we do, we go number of ways. Remember, we normally go 5 factorial over. Now this is just one thing. I don't have to now order the O and the O because they're identical. O is the same as O the other way. So it's ordering 5 things, but we've really only got 2 S's that are identical. So when I divide by 2 factorial, I'm dividing by 2 times S. Okay, so it's 5 factorial divided by 2 factorial is 60. Okay, now in the next part of the question, it says number of arrangements of the word sloops if the 2 O's are separated. Now, in part 2, we looked at if the 2 O's are together. So we basically want every other scenario than when they are together. So I can do this question 2 ways. So the 2 O's are separated when they are not together, as in part 2 above. So the number of ways of ordering the letters of the word sloops if the two O's are separated, is going to be the total number of ways, so that's the total ways with no restrictions, minus 60, which is the two O's together, which is 120. Now, so this is part 3, sorry. Now that's the quickest way to do it, all right? So if you ask this question and it's worth a mark, that's the way that you've got to do it. The other alternative is to try and work out where they're all going to be, but that is going to take a long time. S-L-O-O-P-S. If you want to do it the other way, you can say, well, I can have an O there and an O there, that's 1, or 1 there, that's 2, 1 there, that's 3, 1 there, that's 4, okay? Or I could have, so if the O is in the first position, I can go there, like 1, 2, 3, 4. Or if the O is in the second position, and remember I don't want them together, I could have there, or there. I've got 3 ways. And if the O is in the third position, I could go there and there. Okay, so I could go like there and there. So that's what I'm doing, like that. That. 2 ways. And if the O was in the fourth position, I could go there and there, which is 1 way. So adding them all up, I've got a total of 10 ways. Now that is just to arrange the O's. So 10 ways to arrange the O's. Okay, now I still need to arrange the other 4 letters, which are 2 S's and the P and the L. So I've got 10 ways times 4 factorial, because I'm arranging the other 4 letters over, but I've over 2 factorial because there are 2 repeats. Now that is the longer way to do this. Now 4 factorial is 24 divided by 2. That's 12 times 10, again 120. Now you can see that this first method, it was much easier to do it that way. And now for part 4. Now if the O's are together, for part 4, the ways that you can arrange it, if the 2 O's are together and the S's are together, we've got O as a group, S as a group, and L and P. So we're really just arranging 4 groups. So we've got 4 groups in total. Okay, so basically there are no repeats then. So the number of ways of arranging those will just be 4 factorial, which is 24. So remember, you don't have to order the O and the O because they're identical, and you don't have to order the S and the S. Now part B of this question, of the letters in tattoo are there if the 2 O's are to be separated. Now, remember this was guided in part A, so you know what to do. You're going to do the total ways without restrictions, and then let's put the 2 O's together, and then you can subtract. That is really going to be the easiest way, but remember we've got repeating T's as well. So the number of ways without any restrictions, okay, so there's 3 steps actually, is we've got 1, 2, 3, 4, 5, 6 letters over. Now we've got 3 T's, so 3 factorial, and we've got 2 O's, so divided by 3 factorial and divided by 2 factorial. And I think that is 60, okay, so yes it is. Okay, so the number of ways with the 2 O's together. Now if the 2 O's are together, they form a group, and then we've got the A and we've got the 3 T's. So basically we've got, you need to order 5 groups when the 2 O's are together. So we've got 5 factorial over, and we've only got 1 set of repeating t's, and there are 3 repeating t's, so it'll be 5 factorial over 3 factorial, because that's for the 3 t's. And that is 20. You get 20 for that, because that's 120 over 6, which is 20. So therefore, the number of ways with the 2 O's separated is going to be 60 minus 20, which is 40. Now, this is going to be easier to do it this way. Otherwise, you're going to have to start doing all this all over again. Okay? All right. Question here. Find how many ways the letters of the word decisions can be arranged without restrictions. This one's just straightforward. 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. So 9 factorial over. Now we've got 2 i's. So we can see we've got 2 i's, we've got 2 s's. So then we've only got 1 d, 1 e, 1 c, 2 i's, 2 s's, 1 o, and 1 n. So it's 9 factorial over 2 factorial times 2 factorial, which is 90,720 ways. Now in part B, we want to find the ways that the letters of the word decisions can be arranged so that the vowels and consonants alternate. Now, there are 1, 2, 3, 4, 5 vowels, which are D, C, S, N, and S. In other words, we've got 2 S's that repeat, and there are 4 consonants, and we've got E, I, O, and we've got 2 I's in those. So if we want vowel, consonant, and so on, you know, there are 5 choices for first vowel, then 4, etc., then 3. We've done this in other exercises, then 2, then 1, you know, with times all in between. And the consonants, because there are 4 of them, there's 4 choices, then there's 3, then there's 2, then there's 1. Now this really is 5 factorial, so the number of ways is going to be 5 factorial. That's for the vowels, 5 times 4 times 3 times 2 times 1. And the consonants are 4 times 3 times 2 times 1, which is 4 factorial. But remember, in the vowels, we've got 2 S's, so you have to divide that by 2 factorial. And in the consonants, there are 2 I's, so we divide that by 2 factorial as well. And we end up with 720 ways to order those letters of that word. And part C, we want to order it so that the vowels come first and then the consonants. I don't think this is consonants. I don't think it's even going to change it. So we want the 4 vowels first. Sorry, I think I did this wrong, actually, because we've got, sorry, they're consonants. I'm just a little bit tired. Just tired. So I'm just going to do it the other way. 5 consonants, 4 vowels. So that should be C, V, C, V, C, V, C, V, C. You'll still get the same answer. Okay, so it's not going to matter, sorry. Just pick that up. So I've got C, then V, then C, then V, then C, then V, then C, then V, then C. So it's not going to matter. Now in the next one, we want the vowels that come first. So there's 4 of those, and then the 5 consonants. Well, it's just like ordering V, 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 C, 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 C. So that's just going to be 5 factorial. Now, now these must stay in that position and these must stay in that position. So these vowels have to be here. So, sorry, it's not 5 factorial, it's 4 factorial. Oh, that's not working. So it's 4 factorial over, now we know that in the vowels we've got 2 i's, so it'll be divided by 2 factorial. Then the consonants must come here. So times 5 factorial to order these over 2 factorial again, which again is 720. Now, you do not do 9 factorial over 4 factorial times 5 factorial. You're not ordering identical things. These are not identical vowels. Okay, so the vowels that you're ordering are E, I, O, but they have to be in that position. And the consonants are D, C, S, N, S. So you're ordering those. You're not ordering 4 identical vowels, 5 identical consonants. If you were, you'd be doing 9 factorial over 4 factorial times 5 factorial, but they're not identical. And these also have to stay here in the first 4 positions. So otherwise you'd be mixing them all around if you did 9 factorial, okay? And in the last question, part D, it says so that N is somewhere to the right of D. Now, we know that there is only one N and one D, so that's going to be in half the cases. So this will occur, we've seen this question a few times before, in half of the cases. So we'll look at the cases without restrictions, so it will be a half of 90,720, which is 45,360. Okay, now I want you to work on exercise 9F, and you can do any questions that are not done so far. So you can do all of question 1, all of it, except for the one that we already did. Actually, no, you don't need to do every single one. You can just do a couple from there. Maybe do question 1G and I. You can do question 2 we've done. You can do question 3. You can do question 4. So you've got 1G and I. Question 3 and 4. Question 6 we haven't done. Question 7. We've done 8 and 9. And then you can do 10 through to 13. You don't need to do 14. You can do 15 and you can try 16 as well. That one might be a bit harder. It requires some guessing and checking. Okay, and in the next video I do go through some of the problem question, like some of the harder questions that you might encounter. Okay.